So now task B. They say for each problem set, choose 2 to solve. I'm thinking I only want to solve one of them. And then you should be able to solve the rest, okay? I'll do my best, you guys, to solve the trickiest one so that you can definitely do the others. And it does look to me like these guys are the trickiest ones, okay? Problem set 1. All of these, you guys will notice, is just a number on one side and then a fraction that involves x in the denominator on the other side. So the strategy for all of them could just be to multiply whatever the denominator is by both sides, okay? So in this case, it's x plus 1. We can multiply this side by x plus 1 and this side by x plus 1. And then cancels out right there. And then we get x equals, and then on this side, don't forget to distribute. No matter how ugly the number, don't be afraid of it. You're allowed to use a calculator. Use it if you must. This is 0.90x plus 0.90. Okay? And now I want my x's on the same side. This is a 1x. So I'm going to move the 0.90x because it's smaller. Not just that. I actually don't want to leave one side of my equation empty. Technically, it wouldn't be empty. It'd have a 0. But it does cause a lot of little mistakes from you guys. You forget that you even had an equal sign, and things get really weird when that happens, so just don't do it. Okay, this becomes 0.1x equals 0.90. You could put that 0, you guys. It's totally optional because we don't need zeros at the very end after a decimal point. And now you divide both sides by 0.1. And x equals 9. And 9 is not a violation, you guys. Here, the only violation would have been -1. X could not equal -1 because it would put a 0 in the denominator. And then x is 9, okay? You guys, I literally just did a million problems like this in the 4748 homework. So if you need more explanations and stuff, go back and look at those, please. Okay. Next one. This set. Cross multiplication can totally be your friend with these types of problems. Fraction equals fraction. Boop, boop. If you want, all right? I still like the get a common denominator, forget the common denominator method. Okay? In order to be successful here, you do need to know how to factor difference of squares. You guys, it's so doable. Please try to learn it, please, okay? X squared minus 9 is just going to be x, and then 3 times 3 is 9, so 3. X plus 3, x minus 3. That's it, okay? I'm just going to tell you what that factors to. Remember, I'm going to do this problem, but just letting you know. Over here, let's do it. In order to see what the common denominator is, I need to know what that is. So I need to factor it. I need to see what multiplies to -14 and adds to 5. So I'm thinking +7 and -2. That means that this right here is 2x plus 4 over x plus 7, x minus 2. And that it equals 7 over x minus 2, okay? And then I can now see that the common denominator for this problem is x plus 7 and x minus 2. Okay? I don't like that this is running into this. Okay. So that means I need to get the common denominator. Remember, get it. So this one already has it. This one needs it. It has an x minus 2. It needs an x plus 7. Top and bottom. Okay? By the way, this denominator means that I cannot have x be -7. I also cannot have x be +2. Because they both would put a 0 in the denominator. Okay, and then now that both my fractions have a common denominator, I forget the common denominator. And I have 2x plus 4 equals, distribute 7x plus 49. And let's solve. Let's go minus 2x, minus 2x. If you want, you can at the same time subtract 49. Okay. And now minus 49, minus 49. And we get, let's go over here. We get negative 45 equals 5x. Divide both sides by 5, and x equals negative 9. All right. It doesn't violate negative 7 or 2, so it's fine. Okay. And then, ooh, I is tricky. Okay. So let me just look through here. Everything looks pretty chill. Okay, if I was doing this one, I would combine these combine. I would write it as x plus 1 over 3. So I didn't have 3 fractions to give a common denominator to, okay? Over here, I suggest you take an x out of these two. Wait, no, actually I don't. Don't do it. Don't do that. Just focus on getting a common denominator. My bad. Okay, this one. Let's get to work. Let's factor this guy. This is going to be what multiplies to negative 4 and adds to 3. It's going to be a 4 and a negative 1. 4 plus negative 1 is 3. 4 times negative 1 is negative 4. So if I'm trying to get a common denominator here, I'm trying to save space because I know I'm going to run out of space. Let me just rewrite it. This one right here is 1 over x plus 4, x minus 1, minus x over x plus 4, and it equals 3x minus 1 over 5 times x minus 1, okay? So that means that my common denominator here is the x plus 4, the x minus 1, and that 5. Okay, so on this one, I need to multiply the bottom and the top by 5. On this one, I need to multiply the bottom and the top by 5, but also by x minus 1. And right off the bat, you guys, my spidey senses are going off because I know this minus sign right here is not so innocent. All right, when I distribute this 5x into here, I actually need to distribute this too. So I need to distribute a negative 5x into there. All right. Okay. I hope you got that. If not, email me and ask me about it. And then now, x was 4. We need that over here on the bottom and on the top. And why did I agree to do this problem? This looks like a lot of work. Okay, now you guys, everybody has a common denominator, so I can forget the common denominator. And so this is 5 times 1, which is 5. And over here, I have negative 5x times x, so it's minus 5x squared. And negative 5x times negative 1, which is positive 5x. And it equals on this side, this times this. So this is 3x minus 1 times x plus 4. So it's 3x squared. This times this is negative x. This times this is 12x. This times this is negative 4. And then these two are 11x. So this equals 3x squared plus 11x minus 4. And then now we solve by moving everybody to one side of the equation. Move it all. Move the 5x squared over to the 3x squared. Move the 5x over to this 11x. And move that over here. So this becomes 0. On this side, everybody goes. And then on this side, we have 8x squared plus 6x minus 9. Okay, this is not one of the 95%. of the time factoring problems. 8 times negative 9 is negative 72. On the bottom, it's a 6. So what multiplies to 72 and adds to 6? And I'm thinking it is 12 and 6. You guys, 72 has so many factors, okay? If you don't know them, just start with 1 and 72. And then take a calculator and divide 72 by 2. And it'll say 36. Then divided by 3. And it'll say 24. And divided by 4. And keep going. And you're going to have a buttload of these by the time you're done. Okay? But then you're going to look at which combinations can add to 6. And really, most of them cannot. And you'll land at 12 and 6. The 12 positive and the 6 negative. Okay? And now that I have this, I got to go to this box and put 8x squared and negative 9 and these two, and then factor. What can I take out of 8x squared and 12x? I can take out of 4x. And what can I take out of negative 6x and negative 9? A negative 3. What can I take out of 8x squared and negative 6x? I could take out a 2x. And out of these two, I can take out a 3. And then I get that this guy factors into 4x minus 3, 2x plus 3, which means that x equals the opposite of that number divided by that number, and x equals the opposite of that number divided by that number. How did I do that? Essentially, you're taking 4x minus 3 equal to 0, 2x plus 3 equal to 0, and you're solving each of them by moving this, then dividing this, and getting this. Okay? Okay. Can we keep going? We can keep going. Task C. Here is the graph of f of x. Which function matches it? Ooh, good question. Let's see. I like to first identify my... Where did all my highlighters go? That's fishy. My son dropped my whole pencil case earlier. I wonder if he missed those. That's okay. So I'm noticing a horizontal asymptote at 1. I'm noticing a... those aren't mine, no. I'm noticing a vertical asymptote aha. Thank you. Vertical asymptote over here at x equals negative 1. Okay? And that's everything that I'm going to take over here with me. So the vertical asymptote at x equals negative 1 means that I have a x plus 1 in the denominator. A negative 1 would put a 0 in the denominator, which is why that vertical asymptote's there. My horizontal asymptote of 1 tells me that according to Bobo Button, it's not bigger on bottom because the asymptote's not 0, Bobo. It's not bigger on top because there is a horizontal asymptote and bigger on top says none. It tells me that the exponents are the same, and I divided the coefficients and got 1. So this is bigger on bottom. This doesn't have the x plus 1, and it's bigger on bottom. This has an x plus 1. The exponents are the same, and when you divide coefficients, you get 1. And lastly, this one's bad because it doesn't have an x plus 1 in the denominator. Okay, let's keep matching. Match each function to a true statement about its graph. So we have... I would think it's easier to look at the statements and match them up. So a graph with a hole at negative 3. What does that mean? A hole at negative 3 means in the fraction, there's an x plus 3 on the top and on the bottom. There can be any number of more things going on. However, we must have an x plus 3 on the top and the bottom because negative 3 needs to turn it into a 0, and they need to be able to cancel with one another to create a whole, okay? So let's go see. This definitely doesn't have an x plus 3. This doesn't have an x plus 3. This doesn't have an x plus 3. This might have an x plus 3. We got to factor it. What multiplies to 21 and adds to 10? Wouldn't you know it? 7 and 3. This right here is x plus 7, x plus 3 over x plus 3, which is this x plus 3 business I was telling you about. See. Okay. Now we want to graph with a horizontal asymptote of y equals 1. How lucky. We just saw exactly what causes a horizontal asymptote of y equals 1. Okay. This guy has it. Okay. And none of the rest. So let's go. Let me tell you why. This guy has it because look, this is exactly like this in the sense of that we have a degree 1 and a degree 1. The exponents are the same. And then we divide the coefficients and it's 1 divided by 1, which is 1. Why is it not this one? This one's bigger on bottom. So the asymptote's 0. Why is it not this one? This one's top coefficient is negative 1. All right? So the asymptote would not be a positive 1. It'd be a negative 1. Okay? And then this one bigger on top. So no, it's not there. Okay, now let's look at this. A graph with a vertical asymptote at x equals 0. That means I need to have something where a 0 in the denominator turns it into 0. A vertical asymptote comes from a 0 in the denominator, which is a no situation, okay? So let's look over here. A 0 in this denominator gives me a 3. That's fine. 0 here gives me a 3. That's fine. 0 here gives me a 3. That's fine. But a 0 here becomes 0 minus 0, which is a 0 in the denominator. This one's no good. That's the A. All right. And now here's a new function, blah, 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 blah. Sketch it. Write the equation of any asymptotes. Determine the end behavior. That's fantastic. All right, let's do it. I'm going to sketch last because asymptotes help me sketch. I'm going to find the asymptotes first. I see a vertical asymptote at x equals negative 3. I see a horizontal asymptote at y equals, exponents are the same, divide coefficients. 2 divided by 1, which is 2. As far as the oblique asymptote, well, you're never going to have both of these at the same time. And the degree would have to be bigger on top by exactly 1 for that to happen. So we have none. I just want to address it. And as far as holes go, we also have none. Because there's no factor that's the same on the top and the bottom. All right? So now, I've answered B, but I've also answered C because end behavior is your horizontal asymptote. Just like that. Okay? All right. Now let's go look at a sketch. Here's what we do. We put our asymptotes on here. So we go to negative 1, negative 2, negative 3, boop, 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 vertical asymptote. Horizontal asymptote at 2. Do, 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 do. And then you guys, you need to check a point. All right? On the left of the vertical asymptote of negative 3 and on the right of the vertical asymptote. And you want to know, are you above or below the horizontal asymptote? So watch. To the left of negative 3, I can plug in something like negative 5. Okay? So plug negative 5 in here. You could use a calculator if you want, but 2 times negative 5 is negative 10. Minus 1 is a negative 11. And then negative 5 plus 3 is negative 2. And negative become positive, positive. And 11 over 2 is 5.5. And 5.5 is above this asymptote. So to the left, I am above the asymptote. So then you just draw this curve approaching this asymptote and this asymptote right there. Okay? Then you check to the right of -3. Okay? To the right of -3. So you could plug in -2 or -1 or 0 or 1 or 2 or any of these numbers. I'm going to go with 0. So when you plug in a 0, you get a -1 on top over a 3 on the bottom. And -1/3 is below this asymptote. Okay? So we're over here. Just draw the curve for me. Actually, I drew it bad because knowing that at 0 it's -1/3, like I should have had to go like through this. So really, I mean, honestly, it's just a sketch. So I think this is okay. But just because I knew it, I should put the point and then go like this and go like this. But the point is, this is the way it goes. So you guys, please note, they don't always go up. Like they don't always go down on the left and up on the right. And this one didn't start out with like a negative fraction or anything. Okay? So please don't just assume. This relationship here between these x's is more complicated. So just check. Okay. This is still shorter than the homework. Do we think we can finish the last task right here? Choose 2 of the following sets of criteria. Write a rational function that meets it. Okay. You guys, I really like this. Depending on how long it takes me, I might do them all for you guys. So we're going to write a rational function that has a vertical asymptote at 2. So let's call this the fraction bar. That means I have x minus 2 on the bottom. And a horizontal asymptote at -1. That means I have the same degree on the top. And when I divide coefficients, I get -1. So -1 divided by 1 is -1. This is it. You could do lots of other stuff that would also meet this criteria. This is just the simplest way to do it. Now, I could make it -1x plus 7. I don't know. It still has a vertical asymptote here and a horizontal asymptote at these coefficients divided by each other, okay? Over here, a vertical asymptote at 0 means there's just the x on the bottom. And then a horizontal asymptote at 7 means that I have the same degree on the top, and then when I divide the coefficients, I get 7. But I don't want this x and this x to cancel, so on the top, I'll just make it +1. Okay? Over here, a vertical asymptote at 0. So an x needs to be on the bottom. A whole at x minus 7. That means I have an x plus 7 and an x plus 7 that cancel to make a whole. Over here, a vertical asymptote at -10. That makes it x plus 10 on the bottom. Another vertical asymptote at 4, so that makes an x minus 4. And then on the top, you guys, we can have whatever we want. I'll just make it a 1, okay? Whatever we want. You guys, we haven't seen a ton of functions like this with 2 vertical asymptotes. So I'm going to show you just to just to get you familiar with these functions. With 2 vertical asymptotes, you guys, we have this kind of situation where we've got one asymptote, we have another asymptote over here, let's say. I'm going to extend my axes to graph it further for you. And now, you guys, I have 3 curves, okay? I got 3. I have one over here that I got to figure out. Oh, by the way, There is a horizontal asymptote because the degree is bigger on bottom, so 0. So at y equals 0, there is a horizontal asymptote. So we've got 3 of them going on here, okay? Okay. Okay, yeah. So now I need to check what's happening on all these sides of my asymptote, okay? So with like this kind of function, I would check to the left of the negative 10. So maybe like a negative 11 over here. And negative 11 plus 10 is negative 1 on my denominator. The numerator is 1 no matter what. And then negative 11 minus 4 is negative 15. So this becomes 1 over positive 15, which is like ever so slightly above this asymptote. So that means I approach this asymptote and this asymptote with this curve shape, okay? That's what's happening on the left. And the right side of this asymptote, these are the two predictable curves. I can plug in a 5, okay, to the right. And so then in here, I would get 1 over 5 plus 10 is 15. 5 minus 4 is 1, and that's a positive 1 over 15. Again, which is ever so slightly above my horizontal asymptote. So at 5, I'm also really close right here, approaching this asymptote and approaching this asymptote, okay? With the same looking curve on the top and the bottom. Then in the middle, I gotta check. You guys, the middle will approach either this asymptote like this, or this asymptote like this. And then on this side, it'll approach either this asymptote like this, or this asymptote like this. And it can do any combination of these, all right? It can be approaching here and here, here and here, here and here, here and here, all right? All of those are possible. So the way that I like to check is to check like, I don't know, the like close over here and close over here and see what's happening. I personally can tell that it doesn't cross through because I can tell that there's no x-intercept because there's no way the numerator will be 0, and that's how we could get y be 0 is if the numerator were 0, and that's how we get an x-intercept. And that's not possible here. So let's go pick a number like, I don't know, negative 6. And we get 1 over negative 6 plus 10 is 4. And negative 6 minus 4 is negative 10. So this is 1 over negative 40, which is ever so slightly below. And then if I plug in something like 1, I also get 1 over 11 times 1 minus 4 is negative 3. And these multiply to negative 33. 1 over negative 33 is ever so slightly below. So this definitely confirms this type of shape, okay? So you guys, can you see? It's not so dark, but I do want to make sure you can see. This can happen. This is what these guys look like when there's more than one asymptote, more than one vertical asymptote, okay? I'm a little bit thrown here. I would say that this review, it was great, but I just noticed there's not really much in the way of oblique asymptotes. I don't know. Maybe they want you to also do the quiz review, but I'll just show you One more time, you guys. How to find an oblique asymptote. If you have a function like y equals, wait, there was one that had one. This one. This one has an oblique. Oh no, this one had a hole. Just kidding. Okay, let's make it up. Y equals x squared plus 7x plus 5 over x minus 1. So notice how the degree of the top is 1 bigger than the degree of the bottom. That creates the oblique asymptote. And you find it by dividing. You put the x squared right here. You put the x minus 1 on the side. And you just check how many times x goes into x squared. That's x times. And x times negative 1 is negative x. And this is a negative x, but it should be a 7x, a positive 7x. So I have to add 8x, okay? So that means take what you have, negative 1, subtract what you want to get this box. Oh, wait, what? No, I did it wrong. Take what you want. Just kidding. Just kidding. Just kidding. Take what you want, the 7, and subtract what you have, which is a negative 1. And that'll get you negative negative is positive. 7 plus 1 is 8. That'll get you what goes in this box. And then if that's an 8, that's an x, that's an 8x, this must be an 8. And right here, you're done. This right here is the equation of the oblique asymptote. You just have to write it as y equals x plus 8. All right? If I come up here, you guys, and name this a function, like f of x, you cannot say f of x equals x plus 8. Because x plus 8 and this are not the same thing. So f of x is not equal to this. This is the oblique asymptote of f of x. So just write it with a y, okay? Y doesn't link to a specific function, but if you call this f of x, you're linking it to that specific function, okay? And as a final reminder, you guys, please remember asymptotes are equations. You cannot just say x plus 8. You have to say y equals, okay? When I gave asymptotes all throughout this review, I never said it was 2 or 0. I always said x equals 0, y equals 2. Okay? I always said x equals, y equals, okay? So please keep that in mind. See it? I'm not lying. I always did it, all right? And so did the review. Okay, you guys, good luck.